Let me just say a few words, if I may. Why am I so excited? I guess I wear two hats. The first is for those of you who don't know me, and I apologise, my name is Andrew Wilson. My day job is the Chief Executive of Crossrail, and I've held that role for around 4.5 years right now. I've also recently been asked to chair something called the Construction Leadership Council. There are 13 leadership councils that span across from automotive to aerospace to construction and to pharmaceuticals, and lots of things that sit in between. And I'm trying here to get some clues as to what that might mean, so perhaps by the end of the day we can talk about that. And I guess my third hat is I'm also non-exec director of a board that serves the MOD. It's called Defence Equipment and Services. So they are responsible for buying, procuring and servicing fast jets, aircraft carriers and successor submarines. Very interesting. I have to declare an interest in this debate, and I suppose for the last 10 years, 20 years, probably 30 years since I graduated from the army, to try and bring three things together: technology, leadership and human behaviours, and commercial outcomes. And how do those three things sit on the industry that I presume we're all part of and have a love-hate relationship with? And two outcomes from that. And this is why I feel very honoured to be part of Crossrail, because there are good examples on Crossrail of how we're doing two of these things. One is how, through applying technology, people, and commercial outcomes, can you build infrastructure, buildings, houses smarter? How can you take innovation, smart people, commercial incentives, and build these wonderful buildings that we rely on for a whole life cycle better? Smart delivery, how do we do that? And there's some great examples on Crossrail as to where we have our own innovation program, and we're just teasing out a different form of behaviour. And the second thing that I'm interested in is that how do you manage those assets, those assets over a life cycle? How do they not become just dumb buildings, but how do they become smart assets and smart infrastructure? And of course, that is the title of what we're doing here today. As I said, on Crossrail, we're trying to be able to hand Crossrail over twice, once physically and once digitally. And that digital asset will have intelligence linked into it, and that'll be a huge value over the life cycle of that railway system. But with my CLC hat on, smart delivery and smart infrastructure are going to become the modules, the building blocks of everything that I intend to do over about the next 2 years to just recalibrate this wonderful industry to get a better quality of output for the users, for the customers, for the asset owners, for the suppliers, for the innovators, for the research and developers, for everyone within that sector. And the questions that I'm asking myself is, how do you change the norm? Is it through commercial models and through the value of the output? Is it through less smarter regulation on, for instance, the regulated assets? Is it through competition of the supply chain and the value chain that runs through research and development, innovation, and the provision of that smart infrastructure? And if we were to come here in 5 years, and for this country, this nation, to be the envy of the world, because we are the place to go to deliver smart infrastructure and smart delivery, what is it that we would have done differently? Is it the public sector asking consistently questions that force a supply chain to do differently? How do you take all that we know and to make it biddable? And on Crossrail, we only did half of that job. How do you align the smart questions so that the supply chain are invited to answer it? Is it because the supply chain and the research and developers and the innovators, through competition, persuaded the asset owners and the end users that that was the valued output that you wanted? Or is it some combination of the routes between the two? And looking at people who are here to speak, I asked Robert, am I speaking to the converted? Are we speaking to the converted? Are we speaking to the unwashed? Are you here to be converted? Are you here because you are interested in the output? The question is, we'll have a range of people who understand who are trying desperately hard, and those who are frustrated. So I am hugely grateful, Robert, for the opportunity, for you, for your organisation, the fantastic work that Cambridge University are doing, having won the second round of funding, to look at those inputs and outputs of what smart infrastructure might mean. Hugely excited about this day. Very grateful to have the opportunity for us all to come together and to network, hopefully to share some ideas and to take something positive away. I do have instructions that when we're getting quite close to the end of the allocated time, I know Jennifer here is going to wave a railway children-like handkerchief, a white piece of paper. So don't think that we're rude, but we do have to keep to time. There is plenty of opportunity later to talk and to discuss. But for the moment, welcome here to the Royal Academy of Engineers. Now, Robert Mair needs no introduction. I had a father-in-law once who's Field Marshal Lord Inge. When he became knighted, he was called Syringe, and everyone sort of got it eventually. Robert, of course, we call the Lord Mayor. A Fellow of the Royal Academy of Engineering of the Royal Society, of course, Head of Civil Engineering at the Engineering campus at Cambridge, Master of Jesus, Sir Simon Kirby Laing Professor of Engineering. He is unique. There is only one Lord Robert Mair, and he's here to give our introduction.
That's great, thank you. So, Andrew, thank you very much. And can I extend a very warm welcome to all of you here. You're all very special, and this is an invitee-only event. We believe that the subject that we are going to be covering this afternoon is of enormous importance to the infrastructure industry, to the construction industry, and we think that you have an awful lot to offer and indeed to influence. And so we're very much looking forward to hearing your reactions today. You'll see from the programme that we're going to have about 4 presentations, some of which are about CSIC's work so far, and then we're going to have a break, and then we're going to hear from some organisations that are perhaps not directly connected with the infrastructure and construction industry, and we're going to hear some very interesting perspectives from Rolls-Royce and also from the Internet of Things Security Foundation. And then Jennifer, our director of CSIC, will be saying some words about moving forward, and then we'll have a panel discussion for an hour. And I hope that we are small enough, informal enough to get a really good discussion going. I'm just going to say a few things. So there are 3 big questions that I'm going to pose, and I'm sure they'll recur again in the course of the afternoon. I mean, the first one, which we're asking ourselves a lot, what are the key drivers behind investment in smart infrastructure? And there are quite a lot of those, but making the most of what we have, delivering savings within a longer-term investment strategy, identifying priorities for maintenance work, whole life costing, I'm sure we'll be talking more about that as well, and making what we do safer and less disruptive. And so the second question is, well, what are the key challenges that we face in taking forward smart infrastructure? Again, I hope we'll very much address that question. But culture and practice, there is a reluctance to innovate in our sector. Let's face that. It's true, compared with the other engineering sectors. Look at the aerospace world, the automotive industries. They're way, way ahead. So culture and practice. Procurement practice in our sector. We tend to focus on short-term outputs rather than long-term outcomes. And cost models needing to consider whole life costs. And the third question is, what needs to be done to support the sector in driving take-up of these new ideas, these new technologies? We need to develop standards. We need to have new standards for sensing and monitoring. We need to accommodate innovation in the procurement process. And that, I think, is something absolutely key, and I hope we will discuss that more. How do we accommodate innovation right up front in the procurement process and not somehow expect it osmotically to happen? We need to find ways of calculating real whole life asset costs right through, and we need to develop new business case tools and indeed commercial frameworks, which I guess is part of the procurement point. So those are the only things I'm going to say about those three main questions. I hope they've sowed some seeds in your minds about what it is that we might be talking about more in the course of the afternoon. And now, I think I'm now going to ask our first speaker to make his presentation, Phil Holland. And Phil is from Laing O'Rourke. He's a structures project manager. He's going to talk about how does your bridge feel, the Staffordshire Alliance. So, Phil, it's all yours.
Thank you. So, good afternoon, everybody. My name's Phil Holland. I'm a structures project manager for Laing O'Rourke, and I'm here to speak to you about the work that we carried out with CSIC on the Stafford Area Improvement Programme, which is a network rail project. I'll also go on to sort of outline the what we see as the wider benefits to the industry. Hopefully this works. So to give you a bit of a background to the project, Stafford Area Improvement Programme is a network rail project. It's a programme of works that runs through the Stafford and Norton Bridge area of the West Coast Main Line. It's being carried out under the first pure alliance agreement for Network Rail, based on an Australian alliancing model. And the Staffordshire Alliance is made up of Network Rail as the owner participant, Atkins, Volcarail and Laing O'Rourke as the non-owner participants. Contract value's around 250 million. And it's collaboratively based, so relies heavily on collaboration between the parties. I'll give you a very brief rundown of the project. So it's predominantly there to improve train capacity on the West Coast Main Line, and it's split up into three sub-projects. First of those projects is what we call LSI, which is line speed improvement, and really small amount of track amendments, overhead line equipment amendments, which increase the line speed of the slow lines up to 100 miles an hour. Package 2 is what we call Stafford re-signalling works, and that is the re-signalling of the whole of the Stafford station and connecting the signalling down to the Rugby Regional Operating Centre for use and operation. Package 3 is the Norton Bridge flyover works. These are major civil engineering works to grade separate an existing life expired junction on the West Coast Main Line. And it's these works that I'm going to go through now, and it's these works that CSIC have been involved in. Let's try again. There we go. So, a lot of words I know, but ultimately this is a broad scope for the Stafford Area Improvement Programme Norton Bridge works. It's a significant civil engineering works, around about £100 million. Significant earthworks, OLE works, S&C works and utilities diversions. It's predominantly greenfield, but there are some touch points onto the existing West Coast Main Line. I suppose key to CSIC's involvement is the presence of 11 new structures on the project. So both Laing O'Rourke and Atkins, who are one of the non-owner participants, had previous links with CSIC prior to our project. And prior to the forming of the alliance, but it was a meeting at an innovation event actually that led to the CSI project that I'm going to talk about, linking in with the Staffordshire Alliance. CSIC were in need of a donor bridge effectively, within which and onto which they could position fibre optic monitoring equipment with the intention of taking real-time strain measurements. The long-term goal is remote asset intelligence. I think it's fair to say at first that, certainly from my perspective, there's a little bit of resistance, concern over introduction of time into the programme, etc. But with discussion with the guys from CSIC, we could see how we could do something good and bring some benefit to the project. So we chose two completely different structures on the project. The first of which is what we call Intersection Bridge 5. So this is the crux of the whole project. This is us grade separating the West Coast Main Line. It's a standard Network Rail E-type steel half-through structure. So a fairly standard structure for Network Rail, something they have throughout their infrastructure. They have significant numbers of these. What we did is we installed fibre optics into the main two girder beams, top and bottom of these, and into some of the additional the ladder beams that span between those girder beams. We did that on the ground before we then lifted that deck over the West Coast Main Line. So on the far right hand side you'll see the structure in place. So the fibres were put on before it was lifted into position. What we then did was we installed additional fibres into the reinforcement on that deck so that we could understand the composite action between the girder beam and the composite reinforced concrete deck. Once these fibres were introduced, it allowed us to monitor the static and dynamic load response of the structure. The second structure was a slightly smaller structure, but a simply supported pre-stressed beam bridge, about a 10 metre span. And again, we installed fibres into the pre-stressed beams. We did this back at our manufacturing facility at Explore Manufacturing. We did this because it kept the work away from site to a greater or less extent, but it also allowed us to monitor those beams during curing, during load transfer from the pre-stressing strand into the beams, and also during lifting. Once the beams were delivered to site and installed, we then installed additional fibres into the in-situ element of that bridge deck so that we could sort of understand the composite action of that bridge. So this is a picture of some of the CSI team at work. So you've got Dr. Laing Butler on the left-hand side, who's at the Explore Manufacturing Yard in the pre-stressing area, monitoring the beams. I think after the transfer stress has been introduced into the beams. And then you've got Jason Shardlow and Neve Gibbons, two of the three, who are on Bridge 5 installing the fibre optic monitoring onto that structure. It's fair to say they worked through some pretty poor weather, and they also worked pretty feverishly to maintain our programme. So the output of this work, I suppose, the monitoring data so far has been promising. Hopefully, if this runs, as you can see, the system is being tested for plant loading, and this data is now being analysed and interpreted so that we can understand what it's telling us. Very soon we'll have the first train loading data over that structure. We're due to enter that bridge into service over the Easter bank holiday at the end of March, and we'll get some really good data from that when we get train loading, which we'll then do some more analysis on. So Bridge 11, we've got more data from Bridge 11 already because we introduced fibres into the beams in the yard. So it's given us some data in terms of the curing strains. So the curing strains were in line with our expectations, in line with what you would expect a normal pre-stressed beam to strain during its curing process. Interestingly, we also monitored pre-stress losses, so when we actually chopped the strand and introduced pre-stress into the beam, and they were within about 0.5% of Eurocode 2 calculations, which we were quite encouraged by. And as with Bridge 5, we've now got loadings for plant loading, and again, at Easter, we will get some train loadings. So what's the value to Laing O'Rourke, the Alliance, and the industry? Well, it gave us, from a Laing O'Rourke perspective, certainty of the product assurance data. The manufacturer components were seen to be performing as they were expected to. The measurements of strain confirmed that the pre-stress transfer losses accorded with the Eurocode. And importantly, the addition of the monitoring equipment within the components is heavily aligned with Laing O'Rourke's design for manufacturing assembly process and procedure and strategy. And we believe this monitoring to be a valuable client offering going forward in the future. The wider industry value, the system will give us significant data to allow the structure to be reassessed against any new loading requirements. The asset owners will have the load history of the structure throughout its whole life. The structure will give Network Rail an understanding of the in-service performance of its standard design catalogue structure, so it can do a comparison as to whether they perceive that structure to be efficient or not. It also gives the asset owner the ability to tailor their inspection and maintenance regime to target those structures that are performing the worst structurally. And eventually, it will be seen as a health passport for the structure and informing the asset owner how their structure actually does feel. Thank you.
Well, you've given us a great start. Thank you very much indeed for that. The Staffordshire Lunch Programme, I think, is such a good benchmark programme, not just this, but several things. We're going to quickly move on to Chris Dulake. I of course know Chris. Chris is the former Chief Engineer at Crossrail. Chris has worked for AECOM, more recently for Crossrail and Management 2. The programmes he's worked on seem to get bigger and bigger and bigger. And recently labelled Chris as a legacy launch, as a walking legacy. Chris.
Okay, not too much pressure then. So as a walking legacy, where's my pointer? Thank you very much for the chance to address you all, eminent group of people. Uncertainty affects us in many ways, and I think in design and construction of SCL, there are quite a few uncertainties. It's once been described as an art form rather than a science, and those uncertainties come through in some of the materials factors of safety that we use, in the construction tolerances that we apply to what we build, and then how robust those are when we've actually fabricated the works or built the works, the quality of the materials that we incorporate into the works, and some of the lack of detailed understanding of the performance of what we've actually built. And I think it's that final point that I want to talk about here, because it's that understanding of what we built that it was the subject of the work that we've done with Cambridge. So a better understanding of how structures performed when it's constructed, both in the short term and long term, through changes in temperature of the structures and through their loading, I think is of vital importance to us all. And some of the work that we've done here, I think Keith Bowers has picked up on from Crossrail 2, and is looking to apply that systematically from his stations number 1 to 11. And I think it's important that we need to set in the DNA of some of the big projects that we do, the approach that I'm about to describe, or a variation of that approach, because it's only through applying this that we'll be leaner and more efficient and more informed about what we deliver. And I think we'll only ever do that as one group in industry, transferring knowledge in a transparent way. So the example that I wanted to talk to you about was Liverpool Street Station at Crossrail. I don't know, is there a laser pointer on here? Probably not. So I won't try and point. There's a big red circle around the bit that we're going to talk around, which gives it away a bit. So this is looking north, so the west of the station is to the left-hand side, the east of the station to the right-hand side with Broadgate. To the west we have the Moorgate shaft, and below there we have CP5, which is the subject of this presentation. So when we look in more detail at CP5, this is effectively a big Cambridge laboratory, I think, CP5. And it's one of many laboratories that we've introduced onto Crossrail. Moorgate shaft to the left there is the deepest shaft on Crossrail. It's been one of the most complex shafts to build because of the number of tunnels that come into it at different levels, and the significant amount of reinforcement that we need around the wailing beams, the construction of the diaphragm wall. And it was the subject of a big value engineering exercise where we took out some of the temporary works. I think that's for a separate 2-hour presentation that I'm sure somebody will give at some point. But the laboratory here, as I said, is CP5. And in that, in CP5, I would point, but you see the green shaded structure that runs above. CP5 and the connections into CP1, CP2 were done before we build the escalator above, for obvious reason, which is that you don't actively undermine something that you've just created in concrete. So to prevent those ground movements from those two passages affecting the escalator barrel, everything in blue was built first. So here's the sort of the view looking west. You see the arrow at the top there, and I think you can pick out the definition here. You can certainly see the dimensions, and in the middle of the photograph you can see two sort of circular areas that are marked out almost with the cut here line on them in yellow, where you don't have the hedgehog effect with the rebar inserted into the spray concrete lining. So this is the laboratory area, and that gives you the pins there are for fixing rebar and some of our fibre optics to the wall. So this is some very, very nice graphics from 3D analysis. In my day, I can also say that I did use 3D structural programs to design these sorts of openings and these sorts of works. And I'm pleased to say that the technology has moved on, and it was certainly a lot more painful when I certainly did it. These are complex analyses. They're, as we say, they're highly non-linear in the soil properties that are used, and there's a time dependency associated with the curing and the setting of the spray concrete materials. And this has become a bit of an art form. Now, what probably not to, maybe, I haven't said this to you before, Andrew, but one of the things that we did very early on in Crossrail was we recognised that on projects like Jubilee Line extension, as you travel around Jubilee Line, you'll pick up some very big flat openings between the concourse tunnels and the platform tunnels. And because they're big flat spans, they have some very, very big pieces of steel in them. And to get those pieces of steel in, you have to generally dismantle those sills and lintels into sections to fabricate, and they're very dangerous things to put in place. They also take a lot of temporary work to put in place, so they're pretty slow. And at the start of Crossrail, we set out to try and do things differently. So what we tried to do was to create a three-dimensional structure that shed load more effectively. And utilising the change in our computational power in analysing these particular problems. And it was that we set out to do at the start. And we've sort of forgotten about this because we've been on it for so long that it was one of the things that now the industry have adopted and said, well, that's the way to do it. But actually at the start of Crossrail, it was the thing that changed the way that we were going to design these underground works. Of course, the thing that we suffered from was we had no real data on the construction stresses and strains that came in around these linings, so it was all based on analysis and some very good papers that historically went into the subject, but nothing certainly from the live construction laboratory that we were about to have on Crossrail. So what are the additional stresses that come in? You can imagine this circular tunnel's in hoop compression. And so we've got to break out the two areas in red and build the cross passages either side. And as you break those out, the hoop stresses that are running through those red areas are shed into the structure at either side. And what happens is that the crown and the invert of those adits go into tension, so you get some vertical cracking around the crown and the invert, and you get a overstressing of the pillars either side along the axis. And it was the collection of real data from a live breakout of that sort to validate the design assumptions and the FE models, which was really the subject of the installation of fibre optics, which Cambridge undertook. The form of construction there is we adopted an over-thickening for these areas where we're going to break out, so there were 3 layers. Those 3 layers, 200 mil and 400 mil thick, they're built up in separate individual layers of no more than about 100 millimetres in thickness. And they then provide this thick structure which has some tension reinforcement in the crown and invert that enables us to break through and create the openings. Now, so we look at those 2 examples. There are 12 on Liverpool Street and a total of 7,700 metres cubed at Liverpool Street. On Crossrail, that's multiplied by 4. On Crossrail 2, there are 11 stations, so it'll be multiplied by numerous times. So the potential saving in efficiencies in this particular piece of construction are quite enormous. So there were 210 metres of fibre optic cable installed around those opening sets to monitor as we broke out the change in strain and also the build-up in stress as the subsequent layers were applied before we broke out. And during that installation, there we go, the shot of the installation. The most important part of that installation procedure is, of course, that when you're building sprayed concrete, you have to make sure that everything you're building is encapsulated correctly into the concrete. So you can't get any shadowing or any edge effects around those instruments. They have to be correctly installed, and they have to be installed safely. So there's quite a bit of working at height in that construction sequence anyway. But this is an extra operation that clearly went incredibly well. So, what did it tell us? So the data was then post-processed, which is the graphic in the top right, which I won't try to explain. But I think the most important finding there was that those edge effects, that transfer of hoop load into the adjacent lining, only extended for about 3 metres either side of the opening, which is important because the over-thickening in design was significantly more. And of course, then when you look at the improvements that you could make in that particular process, you look at the decrease in the amount of excavated material, the volume of sprayed concrete that you don't have to install. And this isn't normal concrete, this is a chemical mixture rather than anything that you would recognise as concrete. And it is an expensive material to install underground. So any reduction in volume is welcomed. And obviously, because of the volume decrease in SCL, we have an improvement in the safety in that particular activity. So, there's a significant contribution, I think, in this work in improving the uncertainties that there are in this particular process. And that extra data has proven to be invaluable both now, and I know it's being used for design exercises that are ongoing. It will certainly be used in Crossrail 2, but it needs to be part of an embedded process of continual improvement in our design of SCL. I think I would have died to have the data that's now available to us when we were designing these structures 15 years ago, 20. No, let's not go there. So the savings are potentially very significant. And I do hope that we see this taken forward onto Crossrail 2 because as a project, it could have the value from Crossrail 1 easily transported into it. And I think it's to us to specify how that is delivered now so that the next big SCL projects are able to incorporate it successfully. So that's all I have to say, so thank you very much.
Whilst we're going to be tight for time throughout the day, I'm sure, Robin and I did suggest that just one question. If there's any burning questions that you'd like to take now, then please do if not, don't worry.
At this point, do I put my microphone back on? Or
any questions? Yes, we have one from the second. Forgive me if we don't take 10.
Hi, Phil Blythe, Chief Scientific Advisor at DFT. You said you would love to have this data 15 years ago. What would you have done with it?
I would have been able to, rather than drawing flow diagrams for the distribution of stress around some of these openings and being very conservative about the edge effects because we couldn't analyse them correctly, I'd have used that data to home in the way in which we designed some of those opening structures. Particularly, I mean, I was working on the Jubilee Line extension at that time, hence the example that I'm quoting, because we did do some very robust, is the word, designs for those openings, and we could have done a lot better with better data.
Now, Andrew's next door. We must just take his question because we can't miss this opportunity.
It was the same question. Yeah, it's the so what question, which is what have you done? What have you done with the data?
That's right.
That was an interesting answer.
I was hoping I wasn't going to learn too much new about Crossrail. It isn't going to be the case as we go through today. Chris, thank you very much indeed.
Okay.
Third presentation, Andrew Bell, Chief Engineer of Cementation Cementation Skanska, a specialist geotechnical works engineer, has published numerous papers, has worked very closely with Cambridge CSIC, and anything that is underground. Andrew probably knows more about anyone in this room. So, Andrew, we look forward to hearing from you.
Okay, yeah, good afternoon, ladies and gentlemen, and thank you for the opportunity to speak. I'm going to talk about the role of distributed sensors in underground structures, something that's very dear to my heart, very much from a contractor's perspective, because that's where I've been working for the last 5 to 10 years. Okay, I'll provide an introduction to Skanska. There's one or two in the audience that won't need that. But hopefully it will set the scene and give you an idea of why we're interested in this field. Then I'll cover what are distributed sensors, and I think some people have already talked about that. Then I'll focus on why are we interested in underground structures. Then I'll plot out some recent history. I'll cover a couple of case studies, which hopefully you'll find interesting. And I'll conclude with, has CSIC made a difference? And that will be in our view. So, introduction to Skanska. Skanska are a global business. 90% of our work is in construction. The rest is our business streams in development, in residential development, commercial development, and infrastructure development. This is particularly important when we're talking about tools, when we're talking about smart infrastructure and innovation, because as well as being a builder, we're often developer, funder, builder, and maintainer. So where do we work? We're global, but we're active in selective markets. So this just gives you an idea of where we work, the number of employees we have, and our turnover. That's around about 13 billion UK pounds. So Skanska UK in the UK was established in 2000, and again some figures there give you a feel for the size of the business. We've worked on projects such as the Gherkin, M25 widening and Crossrail, and on a number of those projects we've been able to implement and incorporate smart technology and smart processes. So we work across a full range of sectors. And again, in all of these sectors, the smart agenda is very important to us, and innovation is a high priority for us and for the industry. So down to Cementation Skanska, where I spend most of my time and effort. We are a specialist UK-based piling and ground engineering contractor. We're one of the largest. We are also one of the CSIC founding members, so we've been here very much from the word go. And we've got a history of innovation and collaboration. So what are distributed sensors? Well, one or two of the earlier speakers have beat me to this, but we're generally talking about fibre optics. Long cables that can detect changes over very long distances, and they replace often thousands of point sensors, so very useful to us as an industry. They're very robust to both physical corrosion and electromagnetic interference. They can measure two things typically, strain and temperature, and they're particularly important to underground assets, which is where my experience and expertise has been. So why focus on underground structures? So it's not just a geotechnical engineer talking about geotechnical structures. The problems on projects, certainly on projects, problems with the subsurface work, so foundations, shafts, basements, are usually responsible for half of significant project delays. So it's an area as an industry we really need to focus on. They're very costly when things go wrong. Also, they're very difficult and often impossible to see and touch. So we're putting these things in the ground, they're supporting our infrastructure, and unlike the above ground asset, we can't get to them. So sensors are very important in this area. Interestingly, they're nearly all unique. It's very difficult to use off-site fabrication for some of this work. Some of it we can, but some of it we can't. And the environment when we're down in the ground, in tunnels or in shafts, is a high-risk environment. And there are clear safety benefits to using some smart technology, which I'll talk about in a minute. So, the last 10 years of our deployment, this is Cementation, Skanska and Skanska's deployment of distributed strain measurement and temperature measurement. For about 5 years, and this included the recession, where, as you can see there, nothing happened. These bar charts show the meterage of fibre optic strains that we installed in the ground. That's what I like to call a traditional industry research collaboration. So we had PhD students, we had MN students, but it was interesting. It was really more down to the, I suppose, the passion of the individuals as to what went where. There wasn't too much of a plan involved. And then the recession hit. Thankfully, the recession hit, but the CSIC phase started quite quickly after that. So we, in conjunction with other collaborators in CSIC, and Cambridge in particular, started looking at this in more detail with more of a plan. And you can see there over the CSIC phase, whilst we had a reasonably slow start, towards the end, when we've moved towards industrialisation and commercialisation, the values have gone up. And with the values going up, the benefits have gone up as well, because the more we're putting in the ground, the more we're learning. So this bit at the end is what I would class as the commercial deployment stage. And the two case studies I'm going to show sit in and around the green and the blue area. And you'll see there quite a stark increase in utilisation of technology. So, case study number 1. We started in 2011 a Skanska project called 6 Bevis Marks in London. There was an existing structure, you'll see on the right at the bottom there with the gherkin in the background. It was 7 stories high with a double basement. We replaced that with a 14-storey building, and we kept pretty much all of the existing basement and substructure. So we successfully reused much, as you see in the graphic there, everything other than the red is existing, and that's a 3D visualisation of the substructure. The red was additional new piles we had to put in, but much of it we managed to save. The reuse was only made possible by working with Cambridge and CSIC, installing fibre optic sensors, and you can see there some of our colleagues from CSIC in a dusty basement putting fibre optics into 20 metres into the ground, into existing underreams, to have a look at what happened to the building when we knocked it down, so we could learn for future, and we could also validate and re-warrant the structure. So some headline figures on Bevis Marks. Because the substructure was so massive, we managed to save 52% of the mass of the structure and retain it for reuse. We saved over 1,000 tonnes of embodied carbon, and that was just in not having to install a new substructure. There was much more than that in terms of what we didn't have to then do and bring to site. Significant cost programme, environmental and social benefits. Many less wagons came to the site because of what we were able to do. It was carried out, as I say, collaboratively with Cambridge and CSIC, and we won an industry award in 2013 for Best Sustainable Project, which was a great accolade. The second case study, Semoptics. So what is Semoptics? Semoptics, interestingly, is cementation based and fibre optic based. So we pulled the two together and called it Semoptics. It's a new integrity testing method for cast in place underground structure. So anything we put in the ground and we use wet concrete for, we can use this to assess the integrity of it. And it's been developed with and during the CSIC phase. So lots of collaboration between us and Cambridge and Arup, who are one of our partners in this project, took place. So why did we develop it? The picture there shows current industry practice when we're installing diaphragm walls and large piles into the ground of what needs to go on to carry out integrity testing. The operatives there have to put their hands inside heavy cages, often weighing 30 tonnes, hanging from a crane, to get inside and connect up tubes. So we looked at this, and in particular, during the Crossrail days, we started to have recurring incidents. And there's 2 quotes there of incidents that occurred from our safety bulletins. So injuries were not uncommon. It's still used now. But our vision in 2012, again with CSIC, was to quickly find a viable and safe alternative, which we've managed to do. So at the Battersea Station box now, it's our first major commercial use of the Cementation technology. Again, this is a commercial endeavour now, but with lots of support from Cambridge and CSIC. We've installed over 10 kilometres of cable already, and it's been very successful. It's fully replaced the riskier alternative, or the industry standard, of cross-hole sonic logging. There's been visible improvements to well-being and safety, so it's nothing like as physical. It involves a small number of people tie-wiring fibre optics onto the edge of a cage. So very easy. The benefits have been acknowledged by all stakeholders, so all those involved with the project have seen lots of benefits, from safety to speed and to quality. And we just found out last week it's been shortlisted for 2 industry awards, for innovation and for safety. So fingers crossed. So finally, has CSIC made a difference? There's quite a few words here, but I thought it was quite important. Certainly our view is it's enabled partners to jointly develop technology and roll out on lots of demonstration projects. So we've been able to use these lots of times. We've had a number of failures, but it hasn't really mattered because we've done it on small projects at small level. It's fostered and encouraged collaboration, but interestingly, we've seen lots of shared recognition. So we've seen lots of publicity and PR around the importance of it, and shared recognition for all. And CSIC have provided industry-level training on technology that they understood, but we didn't, to be honest. We knew what we wanted to do with it, but we didn't really know how to use it. It's accelerated change. We've seen some of the things we've looked at a step change, more than just an incremental change, which we're so used to. And it's allowed us to achieve that vision of improved safety. And interestingly, less than 6 months ago, we now made the step to invest in our own capability to install these fibre optic sensors ourselves. So we now have full commercial ability to install what was very much a research technology. So just if we look at a typical hype curve and hype cycle, some of you may have seen these. This is the Gartner hype cycle, often used to track technology from its very inception over to a plateau of productivity. You'll see that there's a peak of inflated expectation and a trough of disillusionment, which we've seen many times over the years. What we've seen with our work with CSIC, and hopefully some of the other partners have as well, I've called it the CSIC effect, but it's a smoothing. So I think in that last 5 years, we've seen very much a smoothing with much less of a peak and much less of a trough. So has CSIC made a difference in our view? Yes. So, final thoughts from me. The CSIC model should be encouraged, and I think as we move forward, we're now into CSIC 2. Hopefully we need to keep the momentum we've gained from CSIC 1 and hold on to those benefits. You'll see there from the chart I put up showing numbers of sensors in the ground, the CSIC model for us worked. Skanska will continue to support such models and push innovation. We've seen it make a difference. We want to make more of a difference out there. In the underground sector, underground sensor technology will help us improve our understanding of structures now and in the future, which is very important, and allow better risk management. And if we look at this graphics here, this is a multi-storey high tower development in Leeds. This is a 3D model of the foundation system. The yellow tubes are the piles that were installed in the 1970s. The grey and the red is everything that was installed in 1996. In 2013, we went in and filled all the gaps. So that is a high-value site within the centre of Leeds, and if we don't look at smart solutions and sensors and infrastructure, we're going to make these projects, if we're not careful, uneconomic, these sites for redevelopment. So finally from me, a quote, and I've used this many times, but if we look at probably the most famous quote on sustainable development, I think this fits in very well with the whole smart infrastructure agenda, that we meet the needs of the present without compromising the ability of future generations to meet their own needs. Thank you for listening.
Just hold that for a moment.
Oh, yes.
Really, really fascinating. The story's beginning to emerge very clearly here. The CSIC effect is going to be jingling towards the end. Any questions for Andrew? Anything we need to interrogate from Andrew? Yes, Keith.
As an ex-contractor, who got the gain?
Who got the gain?
Well, there's a big saving there. Who got it?
The,
Just as a percentage.
the client on that one probably took a larger percentage of it, but we got the gain in that, on the Bevis Marks project, I'm thinking the reuse, the gain we got is that because we could offer this technology and this approach, we were able to negotiate the project. So we could negotiate the project at the right price, ultimately, and I didn't put any pound signs up there, just by reusing the existing foundations alone, that they saved well over £1 million. And that's not taking into account all of the other work that would have to have gone on. So the client saved the real big money, but overall, certainly our view is this helps with building new infrastructure and regenerating.
Do you think that was a game changer in knowing what you knew then about sport and health and CSIC? Did that help you win the project?
It did, yeah, I think it did, because we could have done it, some of it ourselves, but we needed a great benefit we've seen from CSIC is the diversity we've had access to. So on that project in particular, we could borrow a PhD student to help us install fibres, and then at a high level we can talk to Robert and others about the whole general approach and whether it was viable or not. So definitely the CSIC interface helped.
And as we had last time, Andrew, the Chief Scientific Officer, how is this going to change Skanska? Is this now the new norm?
I'd like to think it is. I think we need clients and other stakeholders on board as well, because we can only do so much. If you look at the Cementation, that was very much a product that's given us great benefit, in particular safety. And the clients see the benefit as well. But in terms of reuse and smart sensors, we need everybody involved. And to me, the best way to do that is start talking very early. So get the right people involved very early and come up with the right solution.
Any other questions? Yeah.
What was the sort of view about risk that you were taking? So you were sort of trying to quite a new technique, relying on the data as you're not building down to tell you to keep the fires, you manage the risk.
What we weren't just reliant on that technology. We'd done whole desk studies. We'd looked at all the existing records. So we had a very good idea. We knew what was there. What we didn't know for sure, we didn't know exactly what was there. So in terms of the foundations, we didn't know what steel was in them. What could have happened is when the building weight came off it, the whole thing could have heaved and broken all the existing foundations. We didn't think that was going to happen, but there was a risk it could. The only way so that was the last tick in the box. So to be able to tick that box, we needed the smart sensors in the ground, so we could then monitor it while the building came down, and that was the last tick.
Do you think as clients then, how much of your ability to apply that technology and innovation was it about the client asking, and how much was it you pushing towards the client?
I think on the Bevis Marks project, much of it came from us pushing, but some of that, obviously, the success was in many ways the way we pushed and how we sold it to the client and how we showed the benefits. But that client now is an informed client, so hopefully there'll be more asking next time than pushing.
Really, really keen. Mark, Andrew, thank you very much.
Okay.
So our final case presentation before the break is from Mark Enzer from Macdonald Group. It's going to be smart infrastructure, why it has to be the future. And just reading the little preamble here, Mark has been with Macdonald for 26 years. What caught my attention as an engineer scientist is also a fellow of the Institute of Chemical Engineers and has worked extensively for Anglian Water. Now, as a client, Anglian Water shines as one of those organisations who understands not just the capital delivery of assets, but also understands, I think, for themselves, the value proposition of managing their assets over the life cycle. So really interested, Mark, to hear what you say.
Thank you. So good afternoon. I think we've heard three great presentations on on some detailed examples of smart infrastructure. And what I'd like to do now really is talk a little bit more generally about smart infrastructure and particularly why it needs to be the future. So in doing this, first I'd like to present a bit of context, and hopefully this context will show why smart infrastructure must be the future. And then what I'd like to do is introduce a very simple framework that helps us to understand not only what smart infrastructure is, but also how the components of smart infrastructure all fit together. So, global megatrends. I mean, clearly there are all sorts of other megatrends going on in the world just now, but I offer these as the key ones which are affecting infrastructure. And I think you can see these almost as train tracks that humanity's going down. We can't stop it, we can't get off, but we do need to manage within the context of these megatrends. And they particularly affect infrastructure. So we see climate change, which I guess is the biggest and baddest of them all. Resource limitation, which doesn't just refer to constraints on physical resources, but also human resources and a lack of availability of the necessary skills. And population concentration, which is not just about more people, but about more people squeezed into a smaller area. And then investment constraint. Well, really, the global economy is not in a good place, and it doesn't look like it's going to get into a good place anytime soon. So we see these four very negative megatrends kind of pushing us downwards. But maybe there's another one going in the opposite direction, which I'll call digital abundance. And I think I need to just explain what I mean by digital abundance. So I'll start by looking at this graph. So what you see here is the reduction in unit cost of data storage over 35 years from 1980. And you can see that it's fallen through the floor because it's a logarithmic scale, and you see 10 to 6 up there, and it's gone down to 10 to minus 2. But it's not just data storage which has dropped that dramatically. We see the same kind of thing in processing data and transferring data. And so the one which just stands out to me as being amazing is that processing from $1.1 trillion per gigaflops to 8 cents per gigaflops now. It's absolutely amazing. But what we see is that there's a very dramatic reduction in the unit cost of everything to do with data, whether it's collecting data, storing data, moving data around, or processing data. It's just remarkable. And it shows no sign of stopping either. And in any economy where a key resource shifts from being scarce to being abundant, or vice versa, there is going to be some kind of revolution as a result. And so we do see that digital abundance will inevitably lead to digital revolution. And we see that this has already happened in finance, in aerospace, in travel, in media, in retail, but really it's been quite slow in coming to infrastructure. And therefore, infrastructure really is ripe for digital transformation. And yes, there are pockets of digital transformation in infrastructure, and we'll come across a number of those. But I think compared to other industries, it is fair to say that infrastructure has been slow. So this is a key part of the context of digital abundance. The other bit of context that I'd like to set is that of infrastructure maturity. And I've recently returned from the Congo. And in the Congo, there's hardly any rule of law, let alone any contract law. There's no supply chain, And so it's not surprising that infrastructure there is just in the emergent phase. It's really hard to get started when that's the context. And then you can understand there are places like India maybe, which would be in the growth phase, where the name of the game is just to build stuff, where they've got to literally build thousands of kilometres of road and railway and water networks per year. And so in the growth phase, there's just a lot of building. The name of the game is construction. But then there's the third phase, the mature phase. And I think we can define the maturity phase of infrastructure, which is where there's a lot more infrastructure that has already been built than is built each year. And as an example, I'd call on the water sector, which is my own sector. And so we see in the water sector, there's £350 billion worth of constructed assets at the moment in the UK. And each year, we add to it 1.8 billion. And so we see that there's a big throbbing machine of infrastructure in water, and each year we add a little bit. So this is not to say that infrastructure in development is not important, but it is to say that infrastructure in use is very important too. And I think quite often it doesn't get the same kind of billing. And a key thing when it comes to digital transformation is that it applies to both, not just delivery, but also the infrastructure in use. And so that will be a key theme which I keep coming back to. And so if we accept that, then maybe there is a time, the time is now, for a shift in thinking. Because as we shift from the growth phase to the mature phase, we have to change because the situation has changed. And I won't run through this laboriously, but there are just a few of these differences I'd like to highlight. So crucially, in the growth phase, the focus would be on asset creation, but in the mature phase, it would be on asset management. A really key one, I think, is to do with the outcomes for customers, which is really where the customer ends up being recognised as boss. This is the ultimate customer, the user, the taxpayer, the voter. And what becomes more important is the outcome for that customer. And so the starting point is the customer, rather than just going for outputs. You might say then, in this kind of context, that what's important is the whole infrastructure industry rather than the construction industry. And clearly we see more brownfield rather than greenfield, and potentially procurement should be rewarding outcomes and efficiency rather than outputs. And the one which is relevant to the talk today is more software, less hardware. And so I think that there's quite a key shift that we need to get our heads around. But maybe one of the most important ones is to do with an updated definition of what value is. And I would suggest in this new paradigm of mature infrastructure, value should really be defined as the outcome per whole life pound for the ultimate customer, rather than just the constructed output per capex pound. And if we accept this, then this can point towards digital solutions which are not predicated on construction. So all of this means that infrastructure is ripe for transformation. And I think we can see that transformation coming to infrastructure in a number of different ways. Now, this afternoon, I'm not talking about the transformation in delivery. I'm not talking about transformation in integration. I think those are both really interesting subjects, but it's not for now. The one that I want to focus on is the transformation in information management. And if we look at transformation in information management, then I think a good starting point is to recognise that infrastructure is an information-driven industry. Really, it always has been. It's just that we haven't fully recognised it. So I think one of the things which we do need to be doing is to call it out and then do it on purpose. We need to recognise that information is a strategic resource, recognise it as such, and deal with it accordingly. And I guess if we are looking at areas where there has been a bit of transformation in information management, it would be fair to start with BIM, because BIM has been making some big changes. But BIM really is just the beginning, because I think a lot of the people who work in BIM do recognise and admit that it's the I in BIM that's important. It's the information management part of BIM, which is where the value is. And I guess the kind of the basic BIM, the level 2 BIM, does point towards a real improvement in the management of information, particularly between design and construction. But as soon as we get our heads around what BIM can offer us in terms of information management, it very rapidly takes us on to thinking, well, what about taking that same thought onwards into asset management and asset information management? And as this graph shows, as we move up that line, we get more value, we make more progress. But if we're then thinking about taking that same thread further, and I think a key thing to point out is that what connects this, what is the connecting golden thread, is information. If we take that thought further on, where do we get to? If we're getting more progress and more value, if we're getting more connected and we're getting more out of the information we've got, where does it lead us? And I think the answer to that is smart infrastructure. And we just see the beginning in BIM. It's like the tip of the iceberg. It's a promise that isn't yet fulfilled, but we can take it that much further. So we need some kind of definition, because there's a lot of words going around the place. Digital, smart, what does it all mean? And so I'd like to offer just a very simple definition that I hope will help. And I think that what we can see very clearly is that there's a physical world which you're all familiar with, where there's physical assets and physical infrastructure. But also I think we've become more aware of the digital world with digital assets and digital infrastructure. And so if we join those together, it's where the digital overlays onto the physical that we get smart. And that I think is a really nice and easy way to consider this. Now that overlay elsewhere does get called things like the cyber physical system, but smart is a lot easier. And I think that coming out of Davos, there was quite a lot of talk about Industry 4.0, and I think the Germans were making a lot about the fourth industrial revolution, and what they were focusing on was exactly this, but principally looking at manufacturing, which I guess is natural for the Germans. What we're talking about here, I think, is exactly the same thing, but for infrastructure. So clearly where we want to get to is that there's much more overlap, so much more is smart. But I think the reality of where we are at the moment is that digital is quite a lot smaller and smart is very small indeed. So that's a basic definition. What I'd like to introduce now is a very simple framework that describes the physical overlay and gives some shape to what smart infrastructure is. And as such, this is really intended to help to describe smart infrastructure. It's intended to provide a common understanding and some common terminology that we can all use, which then means we can have intelligent conversations on the subject. It's also intended to show how the different components of smart infrastructure fit together. It's trying to give the big picture of smart infrastructure so we know where all the bits fit. And also it tries to summarise the core value proposition of smart infrastructure. So this is the basic model, and it is very, very simple. At the base, we have a data management layer. And so this is really about getting the data from the physical environment, getting the data from infrastructure. And that data can come from many different places. We've heard about some already today. It can come from sensors, it can come from SCADA, from telemetry, it can also come from drone surveys or satellite imagery, it can come from video data, it can come from scraping social media. Basically, it's anywhere that we want to get the data from that relates to the physical assets. And that is multitudinous, and we are maybe only seeing the beginnings of that. So there's also a watch this space here, because I'm sure we can get data in new ways in the future. But really it's about getting the data from the environment. But just getting hold of the data really isn't enough, because we've got to cleanse the data. More often than not, the data isn't that great. Then we've got to structure or tag the data so that it can have some ongoing use. And then we've got to store the data. So there's a whole load of stuff that needs to be done to the data, not just collecting it, but making it available for use, making it useful. But at this stage, it is just data. It's now in a position of being useful data, but it's just data. So we need another layer, and this layer makes sense of the data. And so in this layer, the kind of thing that we would expect to see would be collaborative environments. This is where big data would sit, data fusion, analytics, where we're looking at the data maybe from a number of different sources, mixing it together and getting greater insights. And so this is really where we're adding value to the basic data and coming up with intelligence. And that intelligence is already useful. It already has a value. It has a use to operators and users. And so we've added value to the basic data. We've come up with something where we've made sense of it. But it does point towards another layer above this, which we'd call the decision-making layer. And here, what we'd expect to see would be decision support tools, optimization algorithms, rules-based automation, potentially machine learning. But the output from this are decisions. So it's a higher level, it's greater value. And I guess one of the things to point out on the diagram, and the reason for it being a triangle, is that the higher up you go, the less volume there is, but the greater the value. So we're adding value each time we go up. And the greatest level of value is where we can make these decisions. And the key value proposition is that we make better decisions faster. And this same kind of model works for all sorts of different timescales. So we can look at it at the millisecond to second timescale, which is where the decisions would be automatic operational type decisions. And in most sectors of infrastructure, there's some automation put in there. In my own sphere, water quality would be one of them. If water quality goes outside a particular spec, the water quality shutdown panel would stop the supply, and there isn't a human involved in that. So there's kind of those automatic operational responses down at the millisecond to second level. But then you can see the second to hour level, where there'd be manual operation. The same model applies to hour to day type level for reactive maintenance, maybe week to month for planned maintenance, and then maybe the longest time scale, looking at year to decade for investment planning. And you might even say that it goes on to, say, a century for very strategic planning. But the point of putting this up is to say that that very simple model and the way that data turned into intelligence, turned into decisions, that applies at all of these different timescales. It's basically the same thing. And I think one of the areas where we can easily make an improvement in infrastructure is keeping the data that we use for operational decisions and still making sense of it for investment decisions. More often than not, operational data gets thrown away at the end of the day. Everyone says, thank God we didn't have any alarms, and then that data goes, but it isn't then used and analysed for potential investment decisions. So there's a way that we can get integration across the timescales as well. In addition to the output where we have intelligence and decisions, we can also see that it would generate feedback. And the feedback would enable us to make the lower layers more efficient and more effective. And as I mentioned before, this framework intends to show where all the key components of smart infrastructure fit. So we've heard a lot in the press about things like big data and Internet of Things, about machine learning. All of these things have a position in this diagram. So briefly then, the value proposition. I kind of touched on it already, which is saying that if we connect this up properly, then what it does lead to is better decisions faster and cheaper. And that is what leads to improved outcomes per whole life pound for the ultimate customer. I think there's another way of looking at this which is quite interesting, which is to say that if we're just doing physical enhancements to infrastructure, then the proportion of value added is just in proportion to whatever we've added, which sounds like a truism. Whereas with smart infrastructure, we have the opportunity to add value across the whole of infrastructure via the overlay. And so potentially we can add more value more cheaply through smart infrastructure. So, a number of key thinkers from these organisations that I've shown here have come together, and we've been trying to put together the thinking that I've just presented into a white paper. And the idea is that we would like to publish that white paper quite soon, the intention being to put it out to industry to help progress the conversation. Simply by having a framework that makes sense of the big picture, and simply by putting out terminology which we can use and then talk together, we hope that it will advance the agenda. So I would like to suggest that the digital revolution surely is coming to infrastructure, and therefore we need to get smart. Thank you.
Mark, I found that absolutely fantastic, and a great segue, I'm sure, into some of the other items we're going to talk about this afternoon. We're going to have a break in about 5 minutes, but there's time for questions. So let's just put Mark on the edge for a moment. Simon, I know you're on the Highways England board. Smart motorways is something that I think fit very nicely into that model. Do you have any views, any comments?
Well, I think one comment is interesting. There are only two infrastructure owner-operators represented in the room. That's Highways England and TfL, Holland from TfL. And I think infrastructure operators take a very different view of what is being discussed today, more from the perspective that Mark has outlined. I mean, I think it's very important that we have very good monitoring structures. But if you sat at a conversation at Highways England board about smart motorways, most of the discussion is about customers, information about our customers, information we provide to our customers, a certain amount about assets. But it tends, the information revolution I see taking place right now is in the relationship with the customer and the relationship with the operations space. I think particularly because that is the space in which we're seeing the most immediate results. So for example, Andrew, you mentioned smart motorways. If by providing real-time management of the motorway environment and also providing information to customers, we can get 25% or 20% more capacity out of the existing highway without, with very little construction, putting hard jobs back in use. Then that to us is where the effort should go now.
But I think that's a fantastic example. And Mark, if I may say, I think I've been trying for years to sort of define some of these complex issues into fairly simple language. I've obviously been sort of fiddling with the cyber-physical interface zone, which I'm not going to get out of. But I thought your description of growth in infrastructure, which is sort of measured in construction leadership council terms of less money and faster and perhaps greener, versus maturity that very much looks at this Simon through the customer's eyes about different measures, reliability, availability, life value type measures was really, really very interesting. So I found that very helpful. Any other couple more questions? Then we're going to have a break.
Skanska. I mean, I think your value proposition, is very good because that does link it to the ultimate customer. I can't remember exactly what it said, but it was something like pounds value to the ultimate customer. I think there's, picking up on Simon's point and thinking about the infrastructure clients that we work for, I think many of them are starting to grapple with this whole issue of what does digital bring? What does it allow us to do differently? And I think information to the customer is absolutely one, I think, but it's also really driving the efficiencies of existing and future programs and linking them together. So I also like the model that showed existing infrastructure versus what we're adding to it on a new basis. Okay, that's for water, but you could pretty much repeat it, I guess, across all types of infrastructure. I think the other thing is, we've not mentioned skills, but then when you think of the different skills that we are starting to require and will require over the next 5 to 10 years, it's massively different because people that analyse data are very different to humans.
Great. Any last observation? Can I just sort of thank the 4 presenters so far? Really, really fantastic. Getting these producers going. For me, I think that last is a great segue. We're going to hear from Rolls-Royce in a minute. I was up at Derby looking at the rolling stock for Crossrail being manufactured. 4 have now come off the assembly line. And we went into their technology centre, and I think I'm their sort of best salesperson, because 4.5 kilometres down the road is Rolls-Royce. Rolls-Royce City, of course, going to have in a minute. In real time, understanding the value of the data that comes out of one of their units, which in this case is an aero engine. You may be surprised to hear that in the data centre of Bombardier, 4.5 kilometres away, they too will measure and monitor in real time the data sets coming out of the class 3, 4, 5 trains over their 30-year life cycle. And the reason why Bombardier won the contracts for Crossrail was not because their trains were at a capital cost to beat the industry, they were level, or because they could build a depot cheaper. The reason is because they understood the value set to themselves over the whole life cycle. And I think that this must be the key. Whether you are asset owners and you need to understand what your asset is doing through the construction phase or through the life cycle phase, or whether you are selling services to end users to understand the data that emerges from those sensor points, this has to be the tipping point at which this sector, I think, goes from a growth industry into a material industry. And whilst we all represent our own private data sets with this horrible inconsistency of privacy locked into us, that is our constraint on data sets, look at the value of the asset data sets that go with infrastructure. So far, it doesn't have a lot of privacy with it, and it is endless in terms of the value that it can create. So really, really interesting. Mark, thank you very much indeed. We're meant to have 15 minutes. The chair I've been allowed to drop to 5 minutes over. Could you take a 10-minute break? And could you please come back here in 10 minutes' time? Thank you very much. Let's just hear our...